Greetings everyone. I am Bonus Kagarama, an applied statistician specializing in data analytics and research design. I'm here to help you master data analytics using Python. If you encounter any challenges or have any questions regarding this course, please don't hesitate to reach out. I am here to support you on every step of the way. Let us embark on this exciting journey of knowledge and exploration together. Thank you. This is our course, Python for Data Analytics, Visualization, and Dashboards. Training outlines. We are going to have 3 lessons, lesson 1, 2, and 3. Lesson 1 will be basic and intermediate level data analysis, advanced level data analysis, and expert level data analysis. Okay. Basic and intermediate level data analysis. We are going to see exploratory data analysis, tabulations and charts, renaming the columns, here I mean variables, and the creation of new columns, dropping the variables, dropping the value labels of no interest, and renaming the value labels. Okay. Now, this is our dataset we are going to use. We are going to import this dataset, which is in Excel, to the Jupyter notebook. Our data frame in Excel or our dataset is in the folder called My Data, saved in the documents. Okay. Now, we are going to go to search engine now. Look for OBS. Look for Jupyter notebook. What is a Jupyter notebook? It is a web-based application used for data sciences. Okay. Click on a Jupyter notebook. It is opening. Okay. It is opening. Okay. Voila. Now, my folder called My Data is in the document. Search it in the document. The folder called My Data. There are set of folders here and the files. So search for My Data. Okay. So this is my folder. The folder called My Data. Open it. Okay. Open it now. Go to New, Python 3, okay. This is a Jupyter notebook interface. This cell you see is a command window. So there is an upper menu, there is a plus sign. This sign is for increasing. The cells, increasing the cells or command windows. And the sign of a sizer is for cutting the cells. So you can cut a cell of no interest to you, Cutting the cells. Okay. Now, an arrow pointing to the right is for running the command. Here, there is an arrow pointing down. Okay. It has got code, markdown, raw, NB, convert, and heading. So our main interest is the code and the markdown. Now, code is for running the command. Code is for commands, only for commands. Markdown is changing the command to a text. So now, another usefulness of markdown is changing the colors of the text. We are going to see the two applications, or the applications of the tool. Okay, so you have your cells here, or command windows. You can start by giving your project a title. For instance, data, this is a text I'm going to write the title as a text. So start with the hashtag space data analysis by bonus. Data analysis by bonus, or by Kagarama. Data analysis by Kagarama. Okay, you can see my text is in green color. So I can change the color of my text using markdown. Come here and then choose markdown. So you can see by using markdown, the text of my color, the color of my text changed from green to blue. Now, from here, I can adjust the size. I can increase or decrease the size of my text by increasing and decreasing the number of hashtags. So if it is a single hashtag, you can see how big the text is. Now, by increasing the number of hashtags, you see you decrease the size of the text. By decreasing the size of hashtags, the size of the text increase. Okay. Now, you can choose the color of your interest, if it is a green, blue, or black. Let us change this text to black. Just learn. Okay, this is my title, the title of my project, Data Analysis by Kagarama. Now, before data analysis, before analyzing data, or before importing the data frame, the first thing you should do is to import the libraries. Importing the libraries. The libraries facilitate help in importing and exporting the data frame, and also during the statistical computations. During the statistical syntaxes commands, you use the libraries. Libraries intervene. So we are going to see how to use the libraries during the whole course. Okay, the first thing, we import the libraries. Now, the most famous of libraries for data scientists are Pandas. Import also Matplotlib, matplotlib dot pyplot as plt. There is also Seaborn as SNS, also NumPy as NP. So these are some of the libraries used by data scientists. There are some other libraries of which we are going to use ahead of the during this course as we go further. Okay. Now, after importing the libraries, run the libraries. Great. There is no message error message. Okay, fine. Now, after importing the libraries, okay, sorry, I'm going to explain briefly each of these libraries. Pandas. Pandas is powerful in handling tabular data structures. Here, I mean data that are in the form of tables. It is used in importing and exporting data, data exploration, data cleaning, data exploration, merging, filtering, aggregating, collapsing, reshaping, and so on. So those are the main uses of Pandas. Matplotlib is all about creating various types of plots, plots and charts. And then Seaborn is indeed a powerful library for data visualization. Creating interactive statistical graphics. And NumPy is essential for numerical computing. So we are going to see the applications of each of these libraries. Okay. Now, after importing the libraries, the next step is to import the data frame. Now, you can call your data frame the name you wish. For me, let me call it data underscore project. Data underscore project. You can call it any name you wish. Equal to PD. Why PD? This is Pandas. As I told you, one of the functions of Pandas is importing and exporting the data frames. PD.read Excel. PD.read Excel. Read what? Excel. Meaning that I'm telling my Jupyter notebook to read the database which is in Excel. Since I'm going to import the Excel database or the Excel data frame, I am telling my Jupyter notebook to read it. If it is in starter, it is pd.read underscore starter. Okay. Now, I go to my folder, the folder called my data. Now, and then the data file or data frame is the data expos. Click on it, I open it. So let me copy this path. This is the path. This is the path. Okay. Copying, there is no option for copying. If it is Control A copying, it is copying everything. No, let us write it the way it looks. It is C colon /users /NSL /documents. Okay, let me go on. Okay, this is my data frame. This is my data frame. So the data frame is huge in size. It is huge. So we can decrease the number of rows. Let us limit it to 2 rows because there is no need of having such a huge data frame. Okay. Limiting the number of rows to 2. Now we have only 2 rows. Okay, meaning that the rest of the rows were hidden. Now we are going to start exploring the data. Data exploration. Data exploration. Okay. Why exploring the data? Why data exploration? It's because before data analysis, you should first of all examine your variables. Examine if your variables experience errors. That is the data exploration. You should. It is also checking for some variables, the nature of the variables, so that you should know clearly the variables you are going to use. So that is exploring. You explore the data. Okay. Now to explore the data, let us check for the size. Checking for the size. Yes. Checking for the size of the data frame. Others call it dataset. Checking for the size of the data frame. This is the size is checking for number of rows. Number of rows and the columns. To check for the size of the data frame, increase the number of cells. Okay, we use .shape. Shape. Shape. Okay. Now you bring your data frame, df underscore project dot shape. Here you can see the total rows of my data frame is 50. There are 50 rows and 6 columns. As you can see, there are 6 columns. This is 1 count all regions. Here commodity 3, floor 4, exports in US dollars 5, and the exports in tons 6. Okay. So we have 6 columns of variables and the 50 number of rows. Here they appear 2 rows because the rest were hidden. Okay. Now we can also use .info. .info .info bring your data frame .project .info run. There is an error. There is a message error here. Name df_project, not a project, it is a project. So this is how we detect we read the message errors. So go here, it is a project. Run. So by using this command, our data frame .info, if you compare it with the .shape, you can see .info is more detailed. It indicates more detailed information. So it shows you number of entries, 50 entries, number of rows, the total number of rows are 50, 0 to 49, and the data columns, 60 columns, and the number of columns of variables is 6. It also shows you the type of characteristics of the variables. Country or regions is the data type is the object. The data type for here is integer. Data type for commodity is the object. So the data type for tones is integer. Yeah, so there are some variables here that are string of which need to be cleaned. We are going to see how to clean data cleaning. Yeah, for the next course. Okay. You can also use data type dot d types. This is test dot d types. Bring your data frame. This is the df_project dot d types. Okay, run. You can see also this, using this command, it gives you the data types of each variable, of each column. So it only shows you the data types of each column. Comparing to this command .info, it is more detailed because it gives you it indicates the data types of each variable. It also shows the number of rows, total number of rows, and the total number of variables or columns. So we better use this command because it is more detailed. .info. Okay. Then checking. The statistics of a given or of continuous variables in the data frame. If you say a continuous variable, that is a quantitative variable, or this means quantitative variables. Continuous variables or quantitative variables such as age, height, weight, distance, tons, exports in US dollars, and so on. So those are some of the examples of quantitative variables or continuous variables. These are variables that are okay. We're going to meet such kind of variables during the next courses and how to deal with them. Okay, how to check for the statistics of continuous variables. Okay. Use describe. So it is in a small letter. Describe. Describe. Okay. Increase the number of cells. Okay. Now bring your data frame project dot describe. Okay, you can see these are some of our quantitative variables. Here tons. So it shows the counts, mean, standard deviation, minimum, maximum, 25%, this is lower quartile, 50% median, 75 upper quartile. Okay. And then we can also transposing the above this. Okay, let us transpose it. Transposing the dot t capital T run. So as we run, you can see the statistics comes above. Okay. Good. Okay, we can now check for we can also check for the nature of the category of a given categorical variable. Checking. Okay. Not correct. Checking. Examining. Oh, looking is okay. Looking or checking for a given categorical variable. Checking a given categorical variable. If you say categorical variable, we mean nominal and ordinal variables. Okay. Then here we use df dot project. This we use our data frame variable dot unique. So this is the command we use. Okay. Now df underscore project. I am now calling my data frame, which is called df underscore project. And then after calling the data frame, I call my variable of interest. For instance, let's say let's go back to this our data frame. Let's say, for instance, commodity floor. Let us say, for instance, floor. Okay, floor. We are now going to see the categories or the data labels of our variable, of our categorical variable floor. Dot unique. Run. You can see now our variable, our categorical variable floor has got one export, import, and re-export. It has got 3 value labels: exports, imports, and re-exports. There is also none. This is a missing value. So you can also use this command to examine the missing values, to check for the missing values of given categorical variables. Okay. It also gives the data type, shows the data type of this variable floor. The data type is the object. Okay, fine. Include the number of cells. Voila. Increase the number of cells. Now, how do we detect the missing values? Detecting the missing values. Detecting the missing values. Okay. How do we detect the missing values? Can use you call your data frame, bring your data frame, df underscore, I called it project, df underscore project, dot is null. Okay, run your command. Oh, what's wrong? Okay, fine. Running the command. Now here it shows the dataset, the data frame with the 2 Boolean values. There is false and true. False means no missing value. True means there is a missing value. For instance, checking for this variable or column, count all regions. False has gone. It is a false. So it does not experience any missing value. Yeah. False. I can see. False. It does not experience a missing value. Commodity. False. No missing value. For the variable floor, false, true, there is a missing value. False, true, there's another true here. False, so it means that the our variable floor experiences missing values. US dollars, false, true. Also, US dollars experiences, exports in US dollars also experiences missing values. So that is how we examine the missing values. But not here, not using this command. As you can see, you take time to look for the missing value. Are there missing values for this kind of variable? So it takes you time. It is tiring, a bit tiring. So the user-friendly command to use to examine to give the summary of missing values on each of the variable is use this command sum. Okay, run. So as you run using this command, it gives you the summary of the missing values by column or by each of the category or by each of the variable. 0 means no missing values. There are 5 missing values for the variable floor. There are 3 missing values for the variable exports in US dollars. So that's the user-friendly command to use. Okay. Now, detecting the outliers. Detecting the outliers. Now, what is an outlier? What is an outlier? An outlier is an extreme value. It is the value which is far away from other values, or which is very far away from other values. Most of data values are not dispatched. There is no high distance between most of the data, but you can find that there are some data that are distanced, that are highly distanced from other data. Those are outliers. Those are extreme values. So how do we detect the outliers, the extreme values? To detect the missing values, detect the missing values, we use one box plot and normal distribution curve and the normal distribution curve. Run this. Okay, or let us leave it as it is. So the test, the color of the text depends on your choice. Yeah. Okay. We use box plot and the normal distribution curve. Now here, let us use box plot. SNS, bring your library called Seaborn. SNS. Now, SNS, after bringing your library, you also bring your data frame, df.e. I called it df.project. Okay, and then bring your the variable of interest. For instance, let's say let's say using our data frame, let us say tons. Okay, tons or tons. Let's call it tons. Okay, in tons. Export in tons. Okay, run. We run. Oh, tons SNS. Project tons module. There is an error message here. Module object is not callable. Module object is not callable. SNS. Okay. We are using box plot. Okay, it is SNS dot box plot. Okay, box plot, because we are now using box plot, and then you call your library called Seaborn SNS. Okay, and then you need to use the box plot, and then call your data frame and your variable or column. Run. Good. Yes. So you see how it looks. To avoid such kind of rubbish here, let us do like this. Run. You can see the data, my variable exports in tons experiences two missing values, or some missing values here. This is the median here, this line here. Between this is the upper quartile, and this is the line, the last line here down is the lower quartile. Lower quartile, upper quartile. So between upper quartile and lower quartile, that's where your data are unbiased, are not biased. So if they are outside of these boundaries, either below this boundary or above this boundary, that is an outlier. So it means that this variable tons is sick. It experiences outliers. So if the variable, or if your data contains outliers, they affect the mean, they pull the mean, they make the mean not to be representative. So you need to clean those outliers as values. Okay, thank you. Let's go on, and we can also use the normal distribution curve. SNS dot dist plot means distribution plot. You call your data frame df underscore project, and then include your variable of your interest. You can see this plot. There is an error here. Attribute error. Module Seaborn has no attribute. Dist plot. It is not dist plot. It is dist plot. Okay, run. as you learn, you can see the data are negatively skewed. Our graph is negatively skewed because the longest tail is to the left, so confirming that there is an outlier, or there are outliers. So you can see the similarity of this graph, normal distribution curve, and yeah, so if it is skewed to the left, negatively skewed, it means skewed to the left. Now it means that the outlier is below this lower quartile. If it is skewed to the right, if the longest tail is here, skewed to the right, it means that you are using the box plot, your outliers are above this limit. Okay, so here, as you identify this, the data should be normally distributed. They should look like this. Okay, meaning that they are health. Your data are health. If they look like this, skewed to the left, to the right, it means that your data are sick. You need to treat them. You need to clean your extreme values or outliers. So thank you. If you got interested by this course, subscribe, like and share, and then we'll meet for the next course.